Hello everyone, welcome to my new lecture series on turbines. This is Vignesh, working as an assistant professor in Department of Mechanical and Mechatronics Engineering in SNS College of Engineering. So in this video, we are going to predominantly talk about the jet engines, how it operates, how it enhance the aircraft and airspace travel. So the global aerospace engine market was valued at a staggering $160 billion in 2023, a testament to the critical role of jet engines play in modern aviation. So most of the aviations are most not the most of all the aviations are airspace travels are based on these jet engines, and it enabling the aircraft to fly faster, higher, and for much longer distance than even before. So they are indispensable for commercial flights, military operations, and even space explorations. So we are going to deep dive into the jet engines and how it operates. Basically, it operates on the Brayton cycle. So during the intake stroke, air is efficiently drawn into the front of the engine through a wide intake, preparing it for the subsequent stages of propulsion. So during the flight, if you see a flight, imagine the engines are deployed in the wings, right? So initially the air is drawn and it compressed using the compressor blade. It rapidly increases the air pressure, often by a factor of 30 to 40 times, preparing it for combustion. Then this compressed air then moves into the combustion, where fuel is sprayed and it precisely injected into the compressed air, and it gets ignited. So this result, the hot gases can reach extreme temperatures of 2700 degrees centigrade. So this superheated high pressure gas then expanded through a turbine, and then expelling a rear wave at high velocity. So this high velocity uh, goes via, right, gas. It propels the uh, aircraft to the forward, and the turbine extracts energy from the expanding gases to drive the compressor and fan at the front, completing the continuous Brayton cycle. So there are four types of jet engines are there. One is turbofan. Turbofan is the workhorse of commercial aviation, and uh, it high bypass ratio directs a significant portion of air around the core, resulting in superior fuel efficiency and reduced noise levels. And another one is turbojet, where it's like a General Electric 179 used on F4 Phantom, were predominant in early military and supersonic aircraft. So they generate pure thrust but are less efficient at lower speeds and altitude compared to turbofans. So turbofans are like low altitude uh, uh, engine, whereas turbojet are high. It works only in the high altitude. And turboprop, such as used to turbine to drive the propeller. They are highly efficient at lower altitudes and speeds, commonly found in regional aircraft and cargo planes. So most of the small aircraft, it uses the turboprop. And ramjet, it is designed for hypersonic flight. Ramjet and scramjets, like both are like high speed engines. And so these are all the four types of aerospace jet engines. And key innovations like fuel efficiency, if you consider, the modern turbofans boast impressive fuel efficiency, achieving 15 to 20% better fuel burn per seat mile compared to engines from the 1990s. And through innovations like uh, exhaust nozzle, chevron exhaust nozzle, nowadays these aircrafts are much uh, quieter than the previous one. And the development of advanced materials such as nickel based superalloys and ceramic matrix composites enables engines to operate at much higher temperature, improving efficiency and durability. And full authority digital engine control systems precisely manage engine operations, optimizing performance, fuel efficiency, and overall reliability throughout the flight envelope. And future, like sustainable aviation fluids targeting like uh, reduction of carbon monoxide and carbon dioxide, they are going for this sustainable aviation fuels. And hybrid electric propulsion, it is there in the research. The integration of electric motors as explored in Airbus Zero's concept promises reduced emissions and quieter operations, particularly during takeoff and landing. And as you say, the fossil fuels are getting replaced by the hydrogen fuels. It is also can be deployed in the aircraft engines also. And like using 3D printing techniques are enabling the creation of lighter, more complex engine components, reducing the material waste and reducing the overall aircraft's weight, and it streamlines the production process also. So this is the future of jet propulsion. And this is all about the jet engines and its future. Thank you for watching. This is Vignesh signing off. Thank you.